All right, imagine this. You're standing on a beach 3,000 years ago. The sky above you is this massive, endless dome of color. The ocean in front of you is doing that thing oceans do, shifting between deep and shallow, catching light, rolling in waves. And if you turned to the person next to you and asked them what color any of that was, they would not say blue. They couldn't. Not because they were stupid, not because their eyes were broken, but because, as far as we can tell, the word simply didn't exist yet. Not in their language, not in almost any language on Earth at that point in history. And once you start pulling on this thread, it unravels into one of the weirdest, most quietly mind-bending mysteries in the history of human perception. So let's pull on it. The story usually starts with a guy named William Gladstone. Now, Gladstone wasn't a scientist. He wasn't a linguist. He was, of all things, a British prime minister, 4 separate times actually, which honestly tells you something about British politics in the 1800s. But before politics ate his life, Gladstone was obsessed with ancient Greek literature, specifically Homer, the guy credited with writing the Iliad and the Odyssey. And Gladstone did something almost nobody had bothered to do before. He sat down and counted colors. He went through Homer's work line by line, cataloging every single color reference. Black shows up constantly. White too. Red gets a decent number of mentions. Even yellow and green pop up here and there. But blue is almost completely absent. Not rare, not occasional. Essentially non-existent. And here's the detail that made people's brains short-circuit when Gladstone published his findings. The sea, this massive, dominant, ever-present feature of Greek life, is never once described as blue in Homer's entire body of work. Instead, it's described as wine dark, as in the color of wine, which if you've ever looked at a glass of red wine and then looked at the ocean, you'll notice these two things do not look alike at all. One is a deep reddish purple sitting in a glass, the other is this vast blue-green expanse stretching to the horizon. And yet, that's the comparison an entire civilization apparently found intuitive enough to use over and over again. And it's not just the sea, the sky, which we would obviously call blue without a second thought, is described by Homer as bronze. Or sometimes just not described in terms of color at all. Sheep, according to Homer, were described as the color of violets. Violets. Sheep. If you're picturing a purple sheep right now, congratulations, you understand exactly how confusing this got for scholars trying to make sense of it. So naturally, the first assumption people jumped to was, okay, maybe the ancient Greeks were colorblind. Maybe there was some kind of biological quirk, some evolutionary hiccup that meant an entire population simply couldn't perceive blue light. It's a clean explanation. It fits the evidence. Blue isn't mentioned because blue physically couldn't be seen. Except there's a problem with that theory, and it's a big one. Gladstone's work got picked up decades later by a philologist named Lazarus Geiger, and Geiger did something clever. He didn't just look at Greek, he looked at ancient texts from all over the world. Icelandic sagas, Hindu Vedic hymns, ancient Chinese stories, the original Hebrew version of the Bible, the Quran, ancient Egyptian records that survived, and across almost every single one of these completely unrelated, geographically distant cultures, the exact same pattern showed up. Blue was either missing entirely or was one of the very last colors to get its own dedicated word. Now think about how strange that actually is for a second. These are civilizations that had zero contact with each other, separated by oceans, mountains, thousands of miles, sometimes thousands of years. No internet, no trade routes connecting all of them, no shared cultural exchange explaining why they'd all make the same linguistic choice, and yet they all landed on the same blind spot, if you'll forgive the pun. That's not a coincidence you can explain with, this one culture had bad eyesight. That's a pattern, and patterns like that usually point to something deeper than random chance. So Geiger dug further, and he found something even more specific. Across basically every language he studied, colors seem to get named in the same general order. It's almost like there's a hidden sequence, a universal roadmap that cultures follow as their vocabulary for color develops. Black and white come first, essentially always, which makes sense since those are really more about light and dark than color in the traditional sense. Then comes red, usually pretty quickly after, likely because red is the color of blood and fire, two things that were, historically speaking, extremely important to notice quickly if you wanted to keep living. After red, you typically get yellow and green showing up, sometimes in either order depending on the culture. And then, almost always dead last, arriving after every other major color has already carved out its own word, blue finally shows up, which raises the obvious question. Why blue? Why is blue always the straggler, the last one to the party, showing up after everyone else already has drinks in hand? Here's where it gets interesting because the answer isn't really about the sky or the ocean at all, even though those feel like the obvious blue things surrounding ancient people constantly. The answer is actually about how rare true blue is in the natural, tangible, touchable world. Think about it this way. How many blue animals can you name off the top of your head? A few birds, maybe, some tropical fish. That's about it, and even a lot of those aren't actually blue through pigment, they're blue through structural color, meaning the way light bounces off microscopic structures in their feathers or scales, which is a whole separate rabbit hole we don't have time for today. Now think about blue plants. Blue flowers exist, sure, but they're a tiny minority compared to the sea of reds, yellows, whites, and purples in a typical garden. Blue fruit, blueberries technically, though even those are more of a dark purple-black when you really look closely, with that powdery blue coating just sitting on the surface. Now compare that to red. Red is everywhere in nature. Blood, fire, ripe fruit, sunsets, certain soils, autumn leaves. Ancient humans were surrounded by red constantly, and it mattered to them constantly, because red often meant danger, or food, or warning. Green, same story. Green meant vegetation, meant life, meant this plant might be edible, or this area has water nearby. These colors had survival value. Naming them, distinguishing them quickly, reacting to them fast, that could genuinely be the difference between living and not living. But blue? Blue in the ancient world was mostly just there, in the sky, in the water. Background elements that didn't really require quick categorization because they weren't things you could eat, fight, avoid, or use. Nobody needed to yell, "Watch out, blue," the way they might need to yell, "Watch out, red berries, don't eat those," or "Red, that's blood, something's wrong." Blue simply didn't carry the same urgent, practical weight. So even though ancient humans were absolutely looking at blue things constantly, their brains and their languages didn't prioritize giving that particular visual experience its own dedicated name. It got lumped in with other categories instead, often grouped with black, or green, or sometimes even considered a shade of white depending on the culture and context. Now, this is the part where you might be thinking, okay, but that's about language, that's about words. Surely they could still see blue, right? Their eyes worked fine, they just didn't have a specific word for it. That seems like a totally reasonable, common sense pushback. And for a long time, that was actually the mainstream scientific assumption too. Language is just labeling. The underlying perception should be identical regardless of vocabulary. A rose by any other name, and all that. Except then, in the 2000s, a psychologist named Jules Davidoff decided to actually test this properly, using a group of people whose language still, to this day, doesn't have a distinct word for blue. He traveled to Namibia to work with the Himba people, a group with their own unique color categorization system, one that groups blue together with green under a single term. And what Davidoff found was honestly kind of wild. He showed Himba participants a circle made up of 11 squares. 10 of the squares were a clear, obvious shade of green. One square, sitting among them, was blue. To basically every Western participant shown this same test, the blue square jumps out immediately. It's obvious. It's practically screaming at you from the screen. But for many of the Himba participants, without a specific dedicated word separating blue from green, the task was significantly harder. Some struggled to identify which square was different at all, or took noticeably longer than Western test subjects to spot it, even though, biologically, their eyes were fully capable of detecting that wavelength of light just as well as anyone else's. But then, Davidoff flipped the experiment around, and this is honestly my favorite part of the whole story. He showed the same Himba participants a different circle, this time made up of squares that were nearly identical shades of green, with one subtly different shade mixed in among them. To most Western eyes, all those squares just look like green. Same green, No differences jump out, but the Himba language happens to have significantly more distinct words for different shades of green than English does. And sure enough, the Himba participants spotted the odd square out almost instantly, quickly and easily, in a test where Western participants really struggled and often couldn't tell the difference at all. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. So think about what that actually demonstrates. It's not that anyone in this experiment had worse eyesight. Both groups had eyes that were physically capable of detecting the exact same range of colors. What differed was attention, categorization, and how quickly the brain could sort and flag a difference as meaningful. If your language has already built a mental shortcut, a specific labeled box for a particular shade, your brain notices differences in that area faster and more automatically. If your language hasn't built that box yet, that information still technically reaches your eyes and your visual cortex, but your brain doesn't flag it as urgent or distinct in the same way. It sort of blends into the background, categorized as more of the same, rather than something new. This is a real studied phenomenon, and it even has a name sort of in linguistic circles, related to a broader idea called linguistic relativity, sometimes referred to as the Sapir-Whorf hypothesis, named after the two linguists most associated with developing the concept. The strong version of this idea, the version that claims language completely determines what you're capable of thinking or perceiving, has mostly been rejected by modern researchers because it's just too extreme and doesn't hold up under scrutiny. Ancient people obviously weren't wandering around with a black void where the sky should be, incapable of perceiving anything blue whatsoever. That's not what's happening here, but a weaker, more nuanced version of that idea, the version that says language shapes and influences how quickly and easily you categorize and pay attention to certain distinctions, holds up remarkably well under actual testing. Language doesn't build a wall around your perception, it builds a spotlight. It tells your brain what deserves quick, automatic attention and what can just kind of blur together in the periphery of your awareness. Now, at this point, you might be wondering, okay, so did any ancient culture actually break this pattern early? Did anyone jump the line and start naming blue before everyone else caught up? And yes, actually, there's one major exception, and it lines up perfectly with everything we just talked about, which honestly makes the whole theory even more convincing: the ancient Egyptians. Egyptian language had a specific, dedicated word for blue thousands of years before most other major civilizations developed one. And the reason lines up exactly with the survival relevance theory we just walked through. The Egyptians were one of the very first civilizations on Earth to figure out how to actually produce and use blue pigment reliably and extensively. They mined lapis lazuli, an intensely blue semi-precious stone, and more importantly, they invented what's now called Egyptian blue, considered by many historians to be the first synthetic pigment ever created by humans, made by combining specific minerals and heating them at high temperatures. This blue pigment shows up constantly in Egyptian art, in jewelry, in tomb paintings, on statues, on ceremonial objects. It became important to their culture, their religion, their status symbols, their daily visual world in a way blue simply wasn't important yet for most other cultures at the time. And once something becomes culturally, economically, and practically important enough that people need to talk about it, trade it, request it specifically, and distinguish it from other things, language catches up fast. The Egyptians needed a word for blue because blue had become something worth naming, worth specifying, worth distinguishing precisely because they'd made it valuable and common in their world through technology and trade. Meanwhile, other cultures who hadn't yet figured out reliable blue pigment production, or didn't have easy access to rare blue minerals like lapis lazuli, simply had way less practical reason to bother carving out a whole new word for a color that mostly just sat quietly in the sky and the ocean, doing nothing anyone particularly needed to discuss. This actually connects to something really important that a lot of people misunderstand about how color words develop in the first place. It's easy to assume language just naturally, automatically develops words for whatever colors exist around us, like it's some kind of inevitable checklist a civilization eventually works through. But that's backwards. Words tend to develop for things that matter practically, economically, socially, or for survival. And ancient dyes and pigments struggled with blue in a way they didn't struggle nearly as much with other colors. Reds could be made relatively easily using ochre or certain insects and plants. Yellows came from various minerals and plant sources without too much difficulty. But stable, vibrant blue pigment was genuinely chemically difficult to produce using ancient technology and materials, at least outside places with lucky access to specific rare minerals. So blue wasn't just rare in raw nature, it was also rare in human-made objects, clothing, and art for an enormous stretch of human history, which just compounds the whole issue even further. Even into much more recent history, long after the ancient world, blue dye remained expensive and difficult to produce reliably in a lot of cultures. This is actually part of why blue eventually became associated with royalty and status in various European contexts. Not because blue was inherently prettier or more special than other colors in some cosmic sense, but purely because it was rare, difficult to produce, and therefore expensive. If you could afford to wear vibrant blue clothing or decorate with blue, you were making a pretty loud, if unspoken statement about your wealth and status, simply because most people couldn't easily get their hands on it. So when you zoom out and look at this whole picture together, you start to realize this isn't really a story about ancient people being unable to see a color. Their eyes worked completely fine. The photoreceptors in their retinas, called cones, which are responsible for color vision, were built exactly the same way ours are, structurally and biologically. There's zero evidence of any kind of evolutionary shift in human eye anatomy over these past few thousand years that would explain any of this. If you traveled back in time and showed an ancient Greek person a clear blue sky next to a green field, their eyes would absolutely detect that these are physically different wavelengths of light, reflecting off different surfaces. The raw visual information was always there, hitting the retina exactly the same way it hits ours. What's actually going on here is a story about categorization, about attention, about how the human brain, faced with an overwhelming, continuous, borderless spectrum of light and color, has to somehow chop that spectrum up into usable, communicable chunks in order to talk about it, think about it efficiently, and react to it quickly. And that chopping up process isn't handed to us automatically by biology alone. It's shaped, refined, and taught to us by our language and our culture, starting from the moment we're born and start absorbing the words the people around us use, which honestly leads to a kind of unsettling question if you sit with it long enough. If ancient people had a genuine, measurable blind spot for a color that was, biologically speaking, right there in front of them the entire time, what does that mean for us? What are we potentially failing to notice right now, today, simply because we don't have convenient words for it? There's actually some pretty compelling modern research suggesting this exact thing might still be happening to us, just in less obvious ways. Russian speakers, for example, have two distinct separate words for what English. Speakers just lump together as blue, one for lighter shades and one for darker shades, treated in Russian almost the way English treats red and pink as clearly separate colors rather than just light and dark versions of the same thing. And when researchers tested Russian speakers against English speakers on tasks involving distinguishing shades of blue, Russian speakers were measurably faster and more accurate at telling those specific shades apart. Not because their eyes were biologically superior in any way, but because their language had already pre-sorted that visual information into separate mental categories, giving their brain a shortcut English speakers simply don't have built in. Greek, similarly, has two separate basic words distinguishing light blue from dark blue, and studies have shown Greek speakers process and distinguish those particular shades noticeably faster than English speakers do, for the exact same underlying reason. So this isn't just some quirky historical footnote about ancient people and their weird wine-colored ocean. It's an ongoing, active phenomenon happening in living languages, right now, in the real world, among people alive today. Different languages are essentially running slightly different perceptual operating systems, drawing slightly different lines through the same continuous spectrum of visible light. And those different lines genuinely measurably affect how quickly and easily speakers of those languages notice certain differences. And it goes beyond just color too, honestly. There are languages that don't use words like left and right at all, and instead rely entirely on absolute cardinal directions, meaning speakers of these languages are constantly, instinctively aware of which direction is north at essentially all times in a way that would be exhausting and unfamiliar for most English speakers to even attempt. There are languages with dramatically different systems for describing shapes, textures, even smells, with some cultures having far more precise, distinct vocabulary for sense than English does, and speakers of those languages testing measurably better at distinguishing and remembering specific smells as a direct result. None of this means language is some kind of prison completely trapping your thoughts and perceptions, permanently locking you out of concepts your language doesn't have convenient words for. People can absolutely learn new distinctions, new categories, new ways of perceiving things throughout their lives, and clearly ancient cultures eventually did develop words for blue too, once it became relevant and important enough to their lives. But it does suggest something fascinating and a little humbling about how perception actually works. It's not some fixed objective camera sitting behind your eyes, passively recording an unfiltered version of reality exactly as it exists. It's an active, ongoing collaboration between your raw biological hardware and the cultural linguistic software that's been installed in your brain since childhood, shaping what jumps out at you immediately and what quietly fades into the unremarkable background of everyday experience. So the next time you look up at a clear sky or out at the ocean and automatically, effortlessly think blue, take just a second to appreciate how strange and recent that automatic little mental label actually is, historically speaking. For the overwhelming majority of human history, across nearly every culture on the planet, that exact same visual experience didn't come pre-packaged with that word or that specific mental category attached to it. People were looking at the same physical world you're looking at right now, the same wavelengths of light bouncing into their eyes, but their minds were organizing and prioritizing that information in a meaningfully different way. And maybe somewhere out there, right now, there's some category, some distinction, some important difference sitting right in front of all of us, hiding in plain sight, that we simply don't have the right word for yet either. Something future generations will develop language for, and then look back at us the exact same way we look back at the ancient Greeks and their wine-colored sea, wondering how we possibly could have missed something that, in hindsight, seems so obvious.